CloudQuery has a lot of built-in plugins, but sometimes you need a plugin for something that isn't already covered. This tutorial covers how to build your own source plugin using the new Python SDK. Source plugins are a gRPC service that use an Apache arrow-based type system to represent the table data. This means the data supplied by a source plugin can pretty much be anything, so long as it can be converted into a suitable table format. Using the CloudQuery SDKs is similar across all supported languages. For simplicity, this tutorial will use Python moving forward, but if you want a video tutorial covering another language, let us know in the comments below. To make this tutorial more accessible, I prepared this template repo that handles all of the boilerplate code. While you can build a plugin from scratch, we recommend using this template as it will save you a lot of time. You'll find a link to the template in the video description. Assuming that you're starting with a single table, by using this template you'll only need to modify 4 files. I'll start by cloning the template repo and editing the directory name. The first thing that we need to do is identify the tables that we want to create with our plugin. Conventionally, CloudQuery plugins have a direct relationship between tables and API responses. So let's take a look at the API that we're working with today, XKCD. The XKCD API has 2 endpoints, the root and the specific. Both of these endpoints return an object with the same unsorted structure, containing the month it was published, the number index, a relevant link, the year it was published, any relevant news, a safe title, a transcript, an alt text field for the visually impaired, the URL of the image, the display title, and the day that it was published. Using this, let's define our table. I'll start by renaming the items.py file and the items class. I'm going to call it comics. Next, we'll want to add all of the fields, so we'll start by just copying the order that they arrive in when we make the request. So you'll notice that month is a string, so I'm going to pop this in, and we'll call it month. Then num is an integer, and we're going to use that as our primary key. And then we have year, which is another string. Then news, safe title, transcript, alt, image, title, and day. Now that we have all the fields, let's provide some structure by reordering these fields into something a bit more sensible. So I'm going to move the num to the top. We'll go year, month, day. So if we want to filter by things, we can filter by them in order of magnitude. Then we can go with title, or safe title. And then we'll go with title, then news, transcript, alt, and finally the image itself. The column order doesn't strictly matter, but it does help to keep our tables nice and neat. Next, we're going to rename the class from items to comics. And we'll do the same with item resolver. We're going to rename this to comic resolver. Now that we've written our tables, it's time to start building the API client. To build the API client, we're going to modify the example client. So I'll start by renaming the folder. I'm going to call this comics. Inside here, we have the example client. The first thing I'm going to do is rename this to comics client. Then I'll take the template item iterator and I'm going to rename it to comic iterator. And we'll start to build this out. Now, as you can see, the type annotation here suggests a generator that yields a dictionary, with no send and no return. To implement this, we're going to start by making a request to the XKCD root endpoint, as this gives us the object for the latest comic. If that's successful, then we'll yield the JSON response. Then we'll set up a loop that retrieves each comic between that first one and the oldest comic, yielding the received JSON object each time. As we don't need any authentication for this particular API, let's go ahead and strip that out of the comic client class and update the spec data class to match. Finally, we need to make some adjustments to the plugin class and set our plugin's name and version. Since we've updated the plugin's class name, the very last thing that we need to do is go into the main file and change a couple of things around. So we're going to change the class name here to match, and again here to match. With that all done, we're ready to save and run the project. To test our plugin manually, we can start it up in our IDE, and using the supplied CloudQuery config, we can run CloudQuery sync test config. Now, initially this looks like it's working correctly, but if I just kill this for a second, doing this, we see two things. First, that I'm only getting one row in the database, despite it having pulled many records. And second, that the database table name is incorrect. Going back to the client code, we can see that I have forgotten to decrement the num counter. So we can fix that quickly by saying num minus equals 1. As for the table name, if we go over to our table config, we'll see that I haven't set the name or the title. So let's go ahead and name this. We'll call this comics. In fact, let's call it CQ comics. And then for the title, we'll just call it comics. That's all that we should need to change here. So if I save this and restart our service, then by rerunning the CloudQuery sync test config, we now see that it's taking longer to pull resources. And if we check our database, we can see that it is now getting populated. That's it for this tutorial. If you like content like this, then make sure that you like and subscribe. And if you want to find out more about CloudQuery, check out the links in the description.